Let's start with our today's topic, which is a performance metrics. First, performance, how it perform well, and metrics. It is derived from Greek word metron, which means measure. So performance metrics are a quantitative measure used to evaluate the efficiency and capabilities and effectiveness of the system. It indicates how CPU perform in overall condition. It compares between the CPUs. There are basically 10 parameters by which we can compare any CPU. Various parameters are: first is clock speed. It measures a number of cycles a CPU can execute per second. It is measured in gigahertz. For example, a CPU completes 4 billion cycles in 1 second. So its formula is number of clock cycle upon time taken into 10 to the power minus 9. So 4 into 10 to the power 9 into 10 to the power minus 9, which is 4 gigahertz. Now our second parameter is instruction per cycle. It indicates how effectively a CPU processes instruction per clock cycle. Its formula is instruction executed upon clock cycle. Let's suppose the example we have a CPU executes 2 million instructions in 1 million clock cycle. So its IPC is 2 million upon 1 million, which is equal to 2. Now our third parameter is total instruction per second, which is IPS, which is clock speed in gigahertz into IPC. For example, a CPU has a clock speed of 4 gigahertz and IPC of 2. Then IPS is 4 into 10 to the power minus 9, 9 into 2, which is 8 into 10 to the power 9 instruction per second. Now our fourth parameter is cache hit ratio. Let's suppose we have a cache and the process wants something, then how much times it is found in cache, that is known as cache hit ratio. It measures how often a requested data item is found in cache. Okay, its formula is cache hits upon total cache access, which into 10 into 100. For example, a CPU executes 90 cache hits out of 100 access, then its cache hit ratio is 90%. Now our fifth parameter is power efficiency. It refers to the ability of a system to perform its function while consuming at least amount of energy. For example, its formula is user output process upon input process into 100, which is IPS. User output process is IPS and user input power into 100. For example, a CPU executes 8 billion instructions per second and consumes 80 watt. Therefore, power efficiency is IPS upon power input into 100, which is 8 into 10 to the power 9 upon 80, which is 100 million instructions per watt. Now our sixth parameter is thermal design power. It provided by manufacturer mainly and can be estimated, not exactly calculated, but can be estimated. Power consumed equal to voltage into current. For example, a CPU operates at 1.2 volt and draws 20 ampere current, then power equal to 1.2 into 20, which is 24 watt. Now our seventh parameter is overclocking percentage, which is a overclock formula is new clock speed minus base clock speed upon base clock speed into 100. Let's suppose, for example, a CPU with base clock speed of 3.5 gigahertz is overclocked to 4.2 gigahertz. Then our increase is 4.2 minus 3.5 upon 3.5 into 100, which is 20%. Now our eighth parameter is Sinmin benchmark score efficiency, which is efficiency score, Sinbench score upon power consumption per watt. For example, a CPU has a Sinbench score of 15,000 and consumes 150 watt. Then our efficiency score is 15,000 upon 150, which is 100 Sinbench point per watt. It is basically calculate the how much it scores based on how much watt it consumes. Our ninth parameter is cost performance ratio. It measures how much performance or functionality you get for how much amount of money. Let's suppose you are giving 1,000 rupees for doing the same thing that is provided for 800 or 700 rupees. Okay, its formula is cost performance ratio, which is cost upon performance, and performance to cost ratio, which is performance upon cost. For example, a CPU costs $300 and has a Cinebench score of 20,000. Then cost performance ratio is 300 upon 20,000, which is 0.015 US dollar per point. And performance to cost ratio, which is 20,000 upon 300, which is 66.666 point per USD dollar. Now our last parameter, which is multi-threading performance gain. It measures multi-programming where multiple threads run simultaneously. Okay, it measures how much a task run in a multiple thread as compared to single thread, how much speed up is there in multiple thread as compared to single thread. Its formula is performance gains equal to multi-thread performance minus single thread performance upon single thread performance into 100. Let's suppose, for example, we have a single thread performance of 5,000 and multiple thread performance of 15,000. Then performance gain equal to 15,000 minus 5,000 upon 5,000 into 100, which is exactly of 20%. Now basically what happens, these are all for comparison. These are all for comparison. Okay, let's suppose you have a CPU 1 and you have a CPU 2. Now you have to compare between CPU 1 and CPU 2. Then these are the parameters 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5, 6 by which you can compare between both the CPUs. And by what you want from your CPU, based on that you can actually buy or acquire that, take that CPU into the consideration. Okay, that's all for today. Thank you.